Welcome to our first lecture about research methods in psychology. The first chapter is really about what is science, and science specifically for psychology, right? Um, of course, this is chapter 1 in your Morling book, and you see a picture of it there, for those of you that maybe have not obtained it yet. This chapter, again, is approached from two different angles from the author's point of view of the book. Who uses research and why, and then what really makes up a good scientist, or what makes up scientific thinking. So we'll be looking at, who are producers versus consumers of research, and then what exactly scientists do and how they approach the questions they have about the nature of people, really, and how we think and behave. In my specific field, IO psychology, it's how we approach work questions, right? So how do we ask whether people are happy at work, and whether their happiness at work is related to their maybe performance, or other aspects of their job, or whether parts of their job make them happier or less happy, right? Not that we only look at employee satisfaction, but it is important. Anyway, so first, research producers and research consumers, right? What do we mean by that? Well, producers, of course, are the people who are producing science, right? Making science, as one of my stats professors used to say. So this can be anybody from a research method student all the way up to a scientist. Consumers are also important, of course, in this process, not just making the research, but also utilizing those findings. So therapists, practitioners, all sorts of people that read journals or read distillations of journals, summaries and articles, and other online venues maybe that describe current findings, right? So I think both are important in a sense. And of course, part of that is being a good consumer of research, right? And of course, both of them could use a critical eye when it comes to what research they need to focus on and utilize in formulating either their hypotheses from the consumer or producer role, as well as what studies and maybe what types of studies they should really be consuming or trusting from the consumer role, right? So producers, of course, psychology students, right? You have to produce literature reviews. That is a type of science, right? It's a synthesis of the literature. In graduate school, you participate in research and collect data for things like theses and stuff like that, and of course, in undergrad as well, sometimes through honors programs, McNair programs, things like that. And of course, when you work in a research lab, you produce research by collecting data with a professor or with other students, either through people coming in and getting a net on their head, like that picture there. And I like that because I actually participated in something like that from a buddy of mine in graduate school. The reward was you get a free picture of your brain, but you have to do an hour research study, right? From the consumer role, of course, like psychology students and people in courses have to read research, right? So through book chapters and journal articles and things like that. So there's all sorts of printed online news stories, things like that. And understanding what sorts of research is better to trust, of course, is integral in that process. For papers that you write for this course, you'll have to use peer-reviewed articles from scientific journals for most of your research, right? Here and there, you can use something from a newspaper or an online source, but very sparingly, if any. And of course, for future careers, you want to use research as a means to solidify what you're doing in that career, right? So whether, like I said, a therapist or some sort of practitioner, when they consume that and utilize that in their practice or in their endeavors, they have to back it up by saying this was a good article in a good journal. And they don't know that unless they know what makes up a good article in a good journal, right? So what do you gain by being a critical consumer of information? Well, you become a better scientist, you become a better consumer of research, and that you will be practicing basically evidence-based psychological treatments or interventions, right? Even as an IO psychologist, we want to make sure that we're using the most up-to-date sorts of interventions, methodologies, or even sorts of intelligence tests or ability tests Stuff like the GRE or SAT is under fire as of recent, but there's always been questions of the validity of those sorts of things, right? So knowing, what they predict, for example, is very important, and who they predict what for. If you don't read the research, you don't know that sort of thing, right? So scientists approach, their sort of job slightly differently than the average person, right? Scientists are what we call empiricists. So they're not necessarily using stuff. They want to actually observe facts and utilize those for the sorts of tests and theories that they're trying to develop, right? So not just accepting information, but generating information based on observations that they see. So the simplest definition of empiricism is, observable facts. So scientists rely on observable facts, and they use those to test the ideas that they have, right? We call these theories. They're ideas, right? They're predictions. As a scientist, you want to test predictions using, some sort of data that you collect. Anyway, scientists also tackle applied and basic sorts of problems, right? Especially in my field, IR, there's, issues, problems that arise in the work field. And so what we do is try to approach those, right? Try to solve those problems. We say dig deeper, or the author of the textbook really says dig deeper. I don't think of that, but it's a way of saying that we look deeper into problems. It's not just whether, let's say, SATs are biased, but why they're biased, right? Is there some sort of different sort of stereotype threat going on, or something else that makes it more interesting? So a lot of the questions we asked are somewhat complicated questions. It's not a simple question that we're trying to ask. There's intervening variables that we'll talk about later in the semester, or moderation or mediation going on based on affect or situation or all sorts of things. Anyway, scientists also want to make this public, right? So consumers wouldn't be able to consume unless, producers actually sent that information someplace. So in this case, usually that's a conference, a scientific conference, or some sort of publication venue, scientific journal, right? And then oftentimes those journals are turned into stories for the media, newspaper articles, all sorts of things. And it's important to know that those are distilled in the appropriate way, right? The article later in the semester by Lilienfeld is about exactly this, that sort of mistranslation of findings, in this case about, child abuse, and sort of the power of individuals to overcome this, in a sense, that there's not long-term damage, let's say. But sometimes when the popular press gets it, it turns into, that child abuse is okay. And that was not the point of the article at all, right? It was really looking at long-term implications, probably, of this from a statistical point of view. So that translation from, scientists to the public sphere sometimes is difficult and can cause problems of a serious nature. So going back to empiricism, I mentioned this term, I threw it out, but empiricism, remember that the reliance on observable facts is one of the cornerstones of science, right? We call this the empirical method because it's the method based on observable facts, or research that's empirical is research that's based on empirical or observable facts, something that we collect, analyze, and is somehow verifiable, maybe. In the sciences, it's actually required that you should share your data with others. We mentioned that scientists do this to test theories, right? So part of this is the idea that we come up with some sort of, let's say, prediction based on what we've read or what we've seen. A famous example of this, the Harlow studies, where they looked at sort of the cupboard, and the cupboard being the availability of food versus the contact, or the availability of comfort, and how infants respond. And they collected data and, of course, supported one of the theories. You probably know, as the picture displays, that the monkey chose the comfort versus the food. But this theory is sort of limited. We think now it's not exactly universal that human babies or even monkeys really respond in this way in nature. But it was data to support their theory, right? So it's not that the theory is proven, it's that this data about these monkeys supports this. And that's how the scientific process basically works. We collect data, we either revise the theory based on that data not coming out the way we thought, or potentially we collect more data to further understand what happened, right? But it starts with a theory. We come up with these research questions based on this theory, then we design some sort of, research to collect that data, right? Some sort of methodology, and our hypothesis is formulated from that, and then we either have data that supports that or not, right? And that's when we get to that point of, whether it's supporting or non-supporting, whether we revise that theory or show that that theory has been supported by the data that we collected. And then that cycle keeps going usually. In some cases, you can look up authors that have been working in the same field for many years, maybe decades, trying to unravel this mystery or keep this cycle going, maybe to either further knowledge or further their career. But for whatever reason, that cycle can continue to go and sort of fulfill further sort of theories through data collection. Anyway, so we test theories, right? We do this through that data sort of cycle where we're coming up with theories, collecting data, revising the theory, or collecting more data to further our understanding of that theory. But good theories, or good theories that we're trying to test in the lab, are usually supported by data or not, right? So, that empirical element. It's also important that they're falsifiable, right? Not that you can support them with data, but that the data can actually come back and show the opposite. This is hard to sometimes envision, but you have to ensure that the data that you collect could potentially, show the opposite effect. So is it only able to show support, or can you actually show a lack of support or the opposite effect if possible, right? We also like to think that sort of theories are parsimonious, right? That they're simple, they're not too complicated, even though I just said that sort of we dig deep sort of one simple step at a time. So as you come up with your theories, don't think your hypothesis has to be super complicated or you have to have 3 or 4 hypotheses. You just have to ask the hypothesis that's appropriate to answer the question you have based on the theory you're working with, right? So it's about, whatever, social media, anxiety, whatever. You want to keep it to, maybe 2 variables at a time and not overcomplicate that picture. And remember, we're not proving anything here anyways. We're just adding support or adding extra grains of salt to that weight or that scale of evidence, if you will. One more piece of data, potentially, that can help with that. So I mentioned earlier that this data can be either sort of more basic, as we call it, or more applied. Basic not being that it's asking simple questions, basic being that it's answering just questions about the knowledge or the understanding of psychology, right? So understanding the process more. Applied research is really where we're answering a specific question, right? An educational question, maybe a work question, where there's a specific intervention there, right? In a practical setting. Most of what I do and most of what a lot of people do is somewhere in between, right? So maybe doing some sort of lab research that is talking about a practical issue, but in a very scientific way that's not happening exactly in the field, right? So somewhere in the middle is what we see a lot, but basic, in essence, is really furthering knowledge. Applied is really answering some sort of practical question. That's the major way to think about that division. This comic shows sort of the cycle of research and how it gets sort of dumbed down as a sort of pejorative sort of term, but simplified for the public and maybe lacks what the original authors intended, right? So there's many different ways to think about the minutiae of research. Usually we call those moderators, right? So in this case, I believe they're talking about sort of studying for exams, but sort of mindfulness or personality is really integral in that process. And I think that's what's really illustrated being lost here. So yeah, maybe a practice of, let's say some sort of meditation or mindfulness increases, performance on something like a test, but really the type of person practicing that mindfulness really matters. So a lot of social psychology, for example, looks at these person-by-situation debates that maybe get lost when it's being translated for the masses. So for scientists, really the optimal venue is not a newspaper or a magazine. It's really sharing our results, our support for the theories that have already been out there, most likely, with the immediate scientific community. That could be psychologists, that can be IO psychologists, clinical psychologists, developmental psychologists, based on your specific sort of psychological bend. But we submit these to journals, we submit these to conferences of sort of similar-minded academics to share what we're finding. And a lot of times that can spur other people to sort of adjust their research or collect data using different scales to sort of look at that same phenomenon, which is fun. You'll see trends developed based on conferences and journals. Journals have special issues, for example, where that special issue will all be centered around, let's say, anxiety in testing situations or something like that. Anyways, when we go past that, right, there's benefits and risks to translating our research into journalism, into newspapers, into the public sphere. There's classic illustrations of this, of course, some of which I know from my own experience, hearing stories from graduate students that the data was not showing exactly what the lead author professor was trying to just sort of display or communicate to the journalism crowd that wanted to cover the study. So this can kind of get confusing. One aspect of that is it an important story? Is it something that needs to be covered, right? And if it is, then usually the newspapers will get involved. But the impact of your particular study may be minimal, but the story or the newspaper wants to pump up sort of the value of that. And then, the other side of that is if they do translate it, is it accurate, right? Are they displaying this in the way it's truthful? And that's sort of going back to the Lilienfelden article that's assigned later and available on Beachboard. It's really about that loss of information or that loss of accuracy or motivation through the translation to the public sphere. So, that accuracy is super important. One other classic example of this is Baby Einstein, right? There was some evidence that, these sorts of techniques work to improve children performance in some areas. But, if you play telephone, as your author will talk about in the book, if you play telephone and, one person talks to another, the story degrades over time. And that's sort of what they're trying to emphasize here, is that, over time, the story about how these sorts of techniques can help your child turn into sort of a magic pill. And then Baby Einstein, in the end, was sued and had to give back a lot of money because their products actually did not work as promised. Anyways, one thing I like to conclude with is a quote from a book that I love called Zen and the Art of Motorcycle Maintenance. Nobody ever reads it. I would ask you if we were in person talking about this and no one would raise their hand. Maybe one person would raise their hand and say, I want to read that book one day. And I would try not to laugh. Anyways, Zen and the Art of Motorcycle Maintenance is a great book. It actually has a sort of a subtle psychological theme to it. But the author also talks a lot about the nature of science. And I'm just going to literally read you these two quotes because I think they're perfect for the start of your endeavor into research methods. The first one is, when I think of the formal scientific method, an image sometimes comes to mind of an enormous juggernaut, a huge bulldozer, slow, tedious, lumbering, laborious, but invincible. What he's saying there, or trying to describe, is the idea that science sort of moves forward. We find evidence, we find facts, if you will, and those facts and evidences support our theories. And if they don't, then our theories get thrown to the wayside. So, science keeps rolling, keeps collecting data. Whether people like that data or not, it's there, and it's evidence. The second part of this is is also, I think, pretty apt for research methods. He says that part of the formal scientific method called experimentation is sometimes thought of by romantics of all of science itself, because that's the only part with much visual surface, lots of test tubes and bizarre equipment, and people running around making discoveries. A man with $50,000 worth of Frankenstein equipment is not doing anything scientific if he knows beforehand the results of his efforts, or what the results of his efforts are going to be. A motorcycle mechanic who honks the horn to see if the battery works is informally conducting a true scientific experiment. And the reason that's true is he comes up with a theory, right? This motorcycle is not working because the battery's dead. He comes up with a method, right? The method is if I honk this horn and it honks, that means the battery's working, and that's not the problem. So they run the experiment, right? Honk the horn, battery, horn honks, battery works. You need to revise your theory. But if the horn doesn't honk, it supports that the battery is the problem. Now, given, I think this is very accurate, because that does not necessarily mean that the battery was the problem with the motorcycle to begin with. It just means that maybe the horn and battery are also not working, right? Or also succumbing to the same issue going on. But it's evidence, right? It's evidence for it. So as you collect evidence future in the semester, know that that evidence isn't proving anything. It's maybe adding evidence, right? As physicists and other scientists do, we add evidence that a black hole exists, or we add evidence that this certain type of neutron exists by doing certain measurements and doing certain experiments to try to show their presence. But it's very hard to prove that they're there a lot of the time. So same thing here. We try our best, but we don't necessarily know that we're proving anything. Anyways.